Hello students, today we are going to see a new topic, that is graphs. Graph is a very important tool for physics. Let's see what are the important components of a graph. A graph basically contains two axes named x and y axis. X axis is called the independent axis and y axis is called the dependent axis. Let's consider a simple shape of graph. The point where the graph touches the x axis is called the x-intercept, and the point where the graph touches the y-axis is called the y-intercept. The area enclosed by the graph and the x-axis is called area under the graph. The gradient of the graph is defined as any change in y value divided by a change in x value. These are the important components of a graph. We are going to discuss two basic classification of graph. One is linear, other one is non-linear. Linear means, as you know, it's straight line graphs. The most important property of a linear graph is they have constant gradient. The gradient can be positive, negative or zero or infinite, but throughout every point on the graph the gradient remains constant. But in nonlinear graph, that is the curves, the gradient value continuously changes. The gradient can be either increasing or sometimes decreasing, and the value can be positive or negative. First of all, we are going to discuss different type of linear graphs. One extreme shape of linear graph is a horizontal line. We are going to see what is the gradient of such a line. In order to find the gradient, I am going to use the equation y2 minus y1 over x2 minus x1. You need to choose a point as x1 y1 and another point as x2 y2. You can choose any point as x1 y1 or x2 y2. So let's calculate the gradient here. If you look at the graph, you can see y1 and y2 are exactly same point. y2 minus y1 will be 0. There is no change in y, but there is a change in x because x1 and x2 are different points. 0 divided by any number should be 0. So this line, a horizontal line, will always have 0 gradient. Let's see the extreme opposite case, a vertical line. What is the gradient of a vertical line? So let's consider the same equation, choose 2 points as x1 y1 and x2 y2. If you observe here, x1 and x2 are the same points, but y1 and y2 are different. Means numerator is there, but the denominator will be 0. There is no change in x. Any number divided by 0 is infinite, means very high. So this graph has an infinite or very high gradient. These are the two extreme possibilities of a straight line graph. Now let's see some other shapes of straight line. One of the most common graph in physics is a straight line passing through origin. So let's find the gradient. Here the advantage is x1 and y1 can be at 0. Both x1 and y1 are 0 and x2, y2. In this particular case, you can even do like y over x. No need to go for y2 minus y1 because one point we are taking is at the 0. Only in this case you can do y by x to find the gradient, but otherwise you have to do y2 minus y1 divided by x2 minus x1. The gradient of such a graph will be a constant gradient, not 0, not infinite, but a constant gradient, and you will get a positive answer. At any point if you find the gradient, you will get a positive answer. Every graph is related with an equation. Let's see what's the equation for this particular graph. All straight lines have this equation y equal to mx plus c. This is the equation for every linear graph. M stands for the gradient and c is the y-intercept. In this particular case, the y-intercept is 0 because it's passing through origin. So the equation reduces to y equal to mx. The relation between x and y, you can say y is directly proportional to x because m is a constant. This is the shape of a directly proportional graph, a straight line passing through origin. Now we will see another type of straight line which is not passing through origin. Here also the gradient will be a constant value. The equation is exactly same as the previous equation because it's a straight line, and here the y-intercept is not 0. So we cannot say they are directly proportional. We have to say there is a linear relation between x and y. Just a linear relation, not directly proportional. Now we are going to see another type of straight line. In this particular line, if you find the gradient, using x1 y1 and x2 y2, what you can see is the y2 is 0 and x1 also going to 0. So if you use this equation, y2 is 0 and also x1 is 0. So when you calculate this value at any particular point, what you can see is you will get a negative answer. Gradient will be same throughout, but all the values of gradient what you get will be negative values. So this is a negative gradient straight line. And the equation is exactly same equation because it's a straight line. This has a negative gradient. And if you are asked to tell the relation between x and y, they have a linear relation with each other. Now let's conclude all the positive and negative gradient lines. Any line like this in any quadrant can be in the positive side or in the negative side. All these lines have a positive gradient. Any line in this direction at any side, positive side or negative side, all these lines will have a negative gradient. All the green lines have a positive gradient and all the red lines will have a negative gradient. Let's conclude the discussion about straight line graph. Now let's move on to curves. There are different type of curves possible. Let's see a very simple type of curve. I'm going to explain how to find the gradient of a curve. How to know if the gradient is increasing or decreasing. Is the gradient positive or negative? In order to find the gradient of a curve, we need to plot tangents. These are called the tangents at different points. A tangent is a line drawn to a curve touching just one point on the curve. If you see the initial tangent, it's a horizontal line. A horizontal line has zero gradient. Means this graph has initially a zero gradient and it's increasing. The gradient is going on increasing and it's going to a very high or infinite gradient. So this graph's gradient starts from 0 and going to infinite. Means this graph's gradient is increasing. This is an increasing gradient graph. And if you want to find the gradient at any particular point, what you need to do is draw a long tangent. Then find the gradient of that particular tangent line, choosing x1 y1 and x2 y2 and using the equation for gradient. Different type of curves. This particular graph already we have seen, and I told you need to draw the tangent to find the gradient, and from the tangents what you can understand is the gradient is increasing because it's starting from a horizontal line and going to a vertical line. And if you want to know if the gradient values are they positive or negative, draw a long line in the midpoint somewhere. That line's gradient, already I have shown in the previous slide how the positive and negative gradients look like. So this is a positive gradient line. This particular curve has an increasing gradient and all the values of the gradient at any point will be a positive answer. Now another type of curve. I'm going to find is the gradient increasing or decreasing. So I'm going to draw the tangents. As you can see, the initial tangent is almost vertical and finally it's going to a horizontal line. As you know, a vertical line has a very high gradient and a horizontal line has a zero gradient. The gradient is decreasing. And if you want to know positive or negative values, draw a long tangent in the middle. You will get a positive answer. Now the third type of curve. Let's see what happens to the gradient and is it positive or negative. I'm going to draw the tangents. Initially a horizontal line. Already we have seen a horizontal line will have a zero gradient and it's going to vertical line which has infinite gradient. Means the gradient of this particular graph is increasing from 0 to maximum. To know positive or negative, I'm drawing a long tangent and this incline shows it's a negative gradient. Let's draw the tangent. It's from a vertical line starting and going to a horizontal line at the end. So this is very high gradient going to a zero gradient means the gradient is decreasing. And checking positive or negative, what you can see is the incline shows the gradient is negative. Let's consider a simple example, a uniform motion. Consider a car moving at constant velocity. You are asked to plot the graph of how velocity varies with time. But from the description itself, it's clear that the velocity remains constant. That's the meaning of uniform motion. The equation for this particular graph, the equation connecting velocity and time for uniform motion, is velocity is equal to displacement over time. The area under this graph, the shaded area, will be always equal to quantity on the y-axis multiplied by the quantity on the x-axis, means velocity into time. Which quantity will be velocity into time? So let's do that calculation here. I'm just multiplying velocity into time. I'm cross multiplying. I'll get displacement. So the area under this graph is always the displacement of the body. Now let's plot how the displacement vary with time for this particular motion. In order to know the shape of the graph, for that I have the equation here. This equation can be easily compared with y equal to mx plus c, because on the y-axis you have displacement and on the x-axis you have time, and the y-intercept is 0 because there is no plus or minus here. Since this equation is in the form y equal to mx, it should be a straight line passing through origin. And what is the gradient of that graph? You can see here the gradient of the graph is velocity. So the gradient of displacement time graph is always velocity. Now we are considering an accelerated motion. A car is accelerating from rest. I'm going to plot 3 graphs here. First, the acceleration time. It's moving under uniform or constant acceleration. From the description, I'm getting that I'm not using any particular equation. Now, what is the area under this graph? The relation between acceleration and time is acceleration is equal to v minus u over t. If you want to know the area, you have to multiply y-axis quantity into x-axis quantity. So when you multiply acceleration into time, what you get is change in velocity. So the area under acceleration time graph is always change in velocity. Now I am going to plot the velocity time graph for this particular motion. To know if it's a straight line or curve, I need the equation, and this is the equation connecting velocity and time in an accelerated motion. It's starting from rest. So you can take u as 0. The equation becomes just v equal to at. Velocity is there on the y-axis and time is there on the x-axis. This equation is in the format y equal to mx. So this should be a straight line passing through origin. And what's the gradient of this graph? You can see here the gradient of this graph should be acceleration. Now what's the area under this graph? Already we have seen the area under the graph is displacement. So velocity time graph is more important because both gradient as well as area are equally important. Now I'm going to plot how the displacement of a body in accelerated motion varies with time. First of all, I need an equation. I need to know will it be a straight line or curve. The relation connecting displacement and time is s equal to ut plus half at square. So the equation simplifies to this relation. S is directly proportional to t square. S is not proportional to t, it's proportional to t square. From that you can understand that this cannot be equated to y equal to mx because there's a square in the equation and there's no square on the axis. So this is not in the form of y equal to mx. So it should not be a straight line, it should be a curve. From the equation what you can understand is if the time is doubled, since there's a square, s should increase by 4 times. Means for a small change in x-axis value like this, there should be a bigger change in the displacement. So this is the shape of displacement time graph. In all these examples, we have been using the equation to plot a particular graph, but it won't be very easy all the times. So we are going to now use another method to plot the graph. So we are going to use the gradient of a graph to plot another graph without using the actual equation. In order to plot graphs using the gradient, you should know 2 details about the gradient. First detail, is the gradient positive, negative or 0? Like this is a positive gradient graph, this is a negative gradient graph, and this is a 0 gradient graph. Second question, is the gradient increasing, decreasing or constant? Like this is an increasing gradient graph, this is a decreasing gradient, this is a constant gradient graph. If you get the answers for these 2 questions, easily you can predict the shape of the graph. In the following examples, we are going to use this method. Let's consider the same example but we have already plotted before, but this time I'm going to use the gradient concept. So first I'm plotting acceleration. It's not difficult because it's given in the description. It's uniform acceleration. Acceleration doesn't change. You don't need any gradient or equation or anything to plot this graph because it's already given in the description. Now I'm going to plot. I can see the acceleration is constant and it's a positive value. Now I'm going to plot velocity time graph looking at this acceleration time graph because I know the gradient of velocity time graph is acceleration. So the gradient of the graph I am going to plot here is acceleration. Is the gradient increasing, decreasing or constant? Means is the gradient of the graph I am going to plot here, should it increase, decrease or should remain constant? The answer is already there. Acceleration is constant. Means the gradient of the graph that you are going to plot here should be constant. The second question, is the gradient positive, negative or zero? Again, the answer is there on the left side. Acceleration is positive. Means the gradient should be positive. So I am going to plot a graph whose gradient is constant and whose gradient is positive. It has a constant gradient. At any time you find it will have a constant gradient because it's a straight line. It has a positive gradient. Just remember the lines I have shown before. This is a positive gradient line. Displacement time graph. We know the displacement time graph's gradient is velocity. So I'm going to write down the details about velocity here. Looking at this graph, I can write the velocity is increasing. From 0, the velocity values are increasing. All the values of velocity positive. So I got two informations what I need. First question, is the gradient increasing, decreasing or constant? The answer is right here. Velocity is the gradient and velocity is increasing. So I'm going to plot a graph whose gradient is increasing. From the word increasing gradient, you can realize that you are going to plot a curve because changing gradient means it should be a curve, not a straight line. The second question, is it positive, negative or zero? The gradient is positive because all the velocity values are positive. So I'm going to plot a graph whose gradient is increasing and whose gradient has all positive values. Let's see, the gradient should be increasing. I'm drawing the tangents so that it's easy to identify the shape. So this is increasing gradient and positive gradient, and that is the shape. The next situation we are going to discuss is uniform deceleration. In the previous part, we have seen uniform acceleration. You can imagine a car moving at a very high speed, it's coming to rest. First of all, I'm going to plot acceleration time graph. If the car was moving to the right side and stopping, what will be the direction of its acceleration? As you have seen in the linear motion topic, acceleration always depends on the direction of resultant force. If the car is going to get stopped, means the resultant force is acting against the motion. So if the car is moving towards the right side, its resultant force and its acceleration are towards the left side. That's why it's getting stopped, because it experiences a force against its motion. If you take right side as positive, the acceleration which is acting towards the left side should be negative. And the value should be constant because the question says uniform deceleration. Now I'm going to plot the velocity time graph by using the concept of gradient. The gradient of velocity time graph, as you know, it's acceleration. What happens to the acceleration? You know, acceleration is constant and acceleration is negative. Is the gradient of the graph we are going to plot here increasing, decreasing or constant? The answer is here. Acceleration is the gradient and it's constant. So you have to plot a constant gradient graph here. Means it should be a straight line. The second question, is the gradient positive, negative or zero? You can see here the acceleration every time it's negative. The gradient of the graph you are going to plot here should be a negative gradient graph. So let's see what will be the shape. It's coming with a big velocity, but it's coming to rest. We have discussed positive and negative gradient lines, right? So this is a negative gradient line and the gradient is acceleration. Displacement time graph. We know the gradient is velocity. You can see the velocity is decreasing from a high value. The velocity is decreasing to 0. All the values of velocity are positive. The velocity is to the right side. It's moving to the right side. So velocity is to the right side and the right side we are taking as positive. So the two questions, is the gradient increasing, decreasing or constant? The velocity, which is the gradient, is decreasing. So I have to plot a graph here whose gradient is decreasing. You are going to plot a curve. A curve will have a changing gradient. A straight line will have always a constant gradient. Next question, is the gradient positive, negative or zero? The velocity, all velocity values are positive, means you have to plot a curve with a positive gradient. The gradient should decrease. I'm first plotting the tangents so that you can get the shape of the curve. This is the shape of the curve, which gives a decreasing gradient. You can see from maximum it's going to a zero gradient, so it's decreasing. All the values of gradient are positive. So this is the displacement time graph for this particular motion. This is the next graph we are going to discuss. An object is dropped from a height. First of all, I'm going to plot the acceleration time graph. Acceleration depends on the force. Means if the force is downwards, acceleration should be downwards. The weight is acting downwards. Means the acceleration also will be downward. We are taking upward as positive. Means the downward should be negative. So the acceleration should be negative in this case. A constant value but a negative value. Using this graph, I'm going to plot how the velocity of the dropped ball varies with time. As you know, the gradient of the graph is acceleration. Acceleration is a constant and it's negative. So I'm going to plot a graph here whose gradient is constant and whose gradient is negative. Gradient is constant means the graph should be a straight line. Gradient is negative means the straight line should be inclined to this side. And you can see it should start from 0 because the object is dropped. Now I'm going to plot displacement time graph for the same motion. For that, I should know the gradient is velocity. Now what happens to the velocity? The velocity is increasing. This may be sometimes confusing, but in physics, negative just means the other side. It's on the negative side because it's going downward and upward is the positive direction. Velocity values are all negative. First question, is the velocity increasing, decreasing or constant? It is increasing. So I have to plot a graph of increasing gradient, means I'm going to plot a curve. The second question, is it positive, negative or zero? It's negative. All the velocity values are negative. So I'm going to plot a curve whose gradient is negative and whose gradient is increasing. An increasing gradient but a negative gradient. You can see it's starting from 0 going to a very high value, but it's having a negative gradient. So try to draw the curve using the tangents, and this is the shape. Gradient is 0 at the beginning, it's horizontal. You can see the velocity is 0, gradient is going to maximum, the velocity is going to maximum, the gradient is all negative, the velocity is all negative. Like this, you can again cross check whatever you have drawn is correct or not. An object is thrown upward and we are going to draw the graph until it reaches the maximum height. Acceleration depends on the force. When the ball is going upward, what's the direction of force acting on it? The only force acting on the ball is its weight, and the weight is pulling it downwards. Weight always acts downwards. Since the force is downward, acceleration should be downward, and downward is negative in this case. Using the same graph, I'm going to plot velocity time. I know the gradient is acceleration, and let's see what happens to the acceleration. It's a constant and negative just like previous case. So if you throw a ball upwards or if a ball is dropped downwards, the acceleration is going to be exactly same. It's always downwards. Is the gradient increasing, decreasing or constant? It's a constant gradient graph and it's a negative gradient graph. So constant gradient means it's a straight line and this is the shape. The gradient should be negative because acceleration is negative, and gradient should be constant because acceleration is constant. The displacement time graph. As you know, the gradient is velocity. Now the velocity is decreasing from a maximum value. It is decreasing. Is it positive or negative? The values are all positive. So I got the answers for two questions. The velocity is decreasing. I'm going to plot a decreasing gradient graph. So it should be a curve, then all the values should be positive. So gradient should be positive and gradient should be decreasing. Let's see how to plot this. First I am plotting the tangents. The gradient is decreasing and gradient is all positive. This is the shape. you can cross check maximum gradient at the beginning. So you have maximum velocity at the beginning, zero gradient at the end, you have zero velocity at the end, and all gradients are positive. You can see all values of velocity are positive value. In this example, I'm going to combine the two previous graphs. A ball is dropped and a ball is thrown upwards. When you combine together, you will get a continuously bouncing ball graph. Let's combine the two previous examples together in a single graph. I'm going to plot all the graphs together. Later I'll explain one by one. As you drop the ball, these are the graphs. When it goes up, these are the graphs. So this is the graph for a continuously bouncing ball. So look at only the acceleration time graph. Other graphs we will discuss later. When the ball is coming down, or even if it's moving up, or even if it's again coming down, all the time you can see the acceleration is same. The acceleration is constant throughout and it's negative throughout, because throughout all the time the force doesn't change and it's always downward. That's why the acceleration is always on the same side and constant value. Now you can check the velocity time graph. Velocity is going on increasing and hits the ground, but after that you can see the velocity is on the positive side, because we take upward as positive and downward as negative. That's why velocity has both positive and negative sides. Now let's look at the displacement time graph. It's decreasing to 0, again increasing to maximum displacement, coming back to 0. If you look at the displacement time graph, you can see every time the height to which the ball rebounds, that height is going on decreasing, because energy is transferred to other forms. On hitting the ground, some of the kinetic energy will get converted to heat and sound. The same reason you can see here, the velocity values are decreasing after hitting the ground. I have taken two sample values 10 and 8. This is the velocity with which it's moving upward and it reaches the maximum height where the velocity becomes 0. Again it's coming back and hitting the ground. The going up velocity and hitting the ground velocity should be exactly equal if we assume there is no air resistance. Again, next time, second time when it hits, again the velocity decreases. So the decrease in velocity happens only when the body hits the ground. Another speciality of this graph is all the graphs in velocity time are parallel, because two graphs parallel means their gradient is exactly same, and in this case all the time the gradient should be acceleration due to gravity, and the acceleration due to gravity is always a constant. This is a theoretical graph for a bouncing ball. This is not a very practical graph because we have made a lot of assumptions in plotting this graph. One of the important assumption is the time of contact. What you can see here is the ball is hitting and rebounding exactly in the same time. Means there is no time of contact with the ground. So I'm going to plot again one more graph for the same motion, but this time by considering the time of contact with the ground. It's going down and hitting the ground, but it won't reflect back immediately. There is a small time delay between hitting and going up. So that time delay marked in green color is the time of contact of the ball with the ground. So during this time, there will be a force acting on the ball in the upward direction from the ground. There will be a normal contact force on the ball. That's why the ball is moving up. The force is in the upward direction. So there will be an acceleration in the upward direction only for that moment. That acceleration should be marked on the positive side. So every time the ball hits the ground, there will be a positive force and a positive acceleration because it's upward. But as you can see here, the value of the acceleration will decrease because it's not going to the same height again. So it's falling from a lower height. That's why the acceleration or the force is decreasing, but it will spend more time on the ground after each bounce. You can see the time of contact has increased compared to the first bounce. So the same change will be there even on the velocity time graph. You can see at the first time the gradient of this line is very high, means the acceleration will be very high. But in the second bounce it became less steep, means the gradient is now lower. So you can see the acceleration is lower than the first one. Even in displacement time graph you can see there is a time delay between hitting the ground and bouncing back. Now this example I want to discuss to tell you the difference between plotting a vector quantity and a scalar quantity on graphs. The three vector quantities, displacement, acceleration and velocity. I am directly plotting the shape because already we have seen it before, throwing something upward and coming down. These graphs we have already seen. Now I want to plot the two scalar quantities, that is distance and speed. So looking at the displacement time graph, I am going to plot the distance time graph. What will be the difference? As you can see, when you throw something upward, the displacement will increase, and at the maximum height, you have the maximum displacement. And when it's coming and hitting the ground, the displacement becomes zero. But is it same for distance? No. Initially, it will increase. Even when it is coming downward, the distance will go on increasing. When you throw upward, the speed or velocity should be maximum at the beginning and it will decrease to zero at the maximum height. But what will happen thereafter? Here I have taken negative velocity because if you have taken upward as positive, downward you have to take negative. But is it true for speed? No, speed is a scalar quantity. The speed will increase just like velocity, but not on the negative side. It will happen on the positive side itself because speed is a scalar quantity. The scalar quantities will be plotted only on the positive side of the graph. Let's see one more example. Generally, a lift will be initially accelerating from rest, then it will move with constant velocity for some time, and finally it will decelerate and stop. For this motion, we are going to plot the acceleration, velocity, and displacement graphs. First, the constant acceleration. From the description itself, you will know the acceleration is constant. So, a horizontal line. I am going to draw corresponding velocity time graph. As you know, the gradient of the velocity time graph is acceleration, means I have to plot a graph of constant and positive gradient. How the displacement will look like? The gradient is velocity. So, the gradient should be 0 initially. The gradient should increase, but all positive values. Gradient is 0 and gradient is increasing. This is 0 gradient initially. Horizontal line. It's going to a vertical line, so gradient increases and all positive gradient. In the second stage, it's moving at constant velocity. Constant velocity means acceleration is 0. Then velocity, it's already written there, it's constant. Now displacement. I have to plot a graph whose gradient is constant, because the gradient is the velocity. This is the graph of constant gradient. Now the third stage, deceleration. Deceleration is a negative acceleration. Now for velocity, I have to plot a graph whose gradient is constant and whose gradient is negative. Constant, negative gradient, displacement. What you can see is from the same velocity it's decreasing, means from the same gradient, from the same slope it should decrease to 0. This is the shape of displacement. Now let's plot graphs in reverse. That means displacement time graph is given and you are asked to plot velocity time and acceleration time. So let's say the displacement of a body varies with time like this. What we know is the gradient of displacement time graph will give velocity. So I'm going to see what happens to the gradient of the displacement time graph. The gradient of a curve is found by drawing tangent. You can see initially the tangent goes horizontal, means 0 gradient. Then it's increasing and becoming very high gradient. Means the gradient of the graph in the first half is increasing, means the velocity should be increasing because velocity is the gradient. Is the gradient positive or negative? You can imagine a tangent in the middle and you can see the gradient is negative, means the velocity should be negative. So we are going to plot a graph here. The value should be increasing and all the values of velocity should be negative. This is the shape. Now going to the second half of the motion, let's see what happens to the gradient of this graph. You can imagine tangents, it's very high at the beginning and going to 0. So in the second half, the gradient is decreasing, means the velocity value should be decreasing in the second half. And is the gradient positive or negative? Imagine a long tangent here and you can see the gradient is positive, means all the velocity values should be positive, means the shape of the graph will be like this. You can even join the two lines. Now I'm going to plot acceleration looking at the velocity graph. So first half or second half, you can see all the time the gradient is constant. So the acceleration should be constant throughout. Are they positive or negative gradient? Both lines have negative gradient, means the acceleration should be negative throughout. So this is the shape. We have been plotting graphs using the concept of gradient, but sometimes you will not know what is the gradient of a particular graph. For example, a ball is dropped from a height and you are asked to plot how the velocity of the body varies with displacement, not time. So here you have no clue about what is the gradient of this graph. In such situations, the only option is using the equation or using the relation between the two quantities you are going to plot on the graph. For example, here, velocity and displacement. What is the exact equation connecting velocity and displacement for an object dropped from a height? This is an accelerated motion, and this is the equation connecting the velocity and the displacement of the body. When you drop something, the initial velocity is 0. So the equation becomes v square equal to 2as. Now the problem is we have velocity on the axis, but in the equation it is v square, means velocity and displacement are not directly proportional. So you will not get a straight line between velocity and displacement. If you equate this equation to y equal to mx, the equation for a straight line. Since acceleration is constant, the equation reduces to v square is directly proportional to s. That means if you plot v square against s, velocity square against s, according to this equation, it should be a straight line passing through origin because they are directly proportional. But velocity and displacement are not directly proportional. So the graph will not be a straight line, so it should be a curve. V square is proportional to s, means for a small change in velocity, like if velocity increased 2 times, the left hand side of the equation is v square. The left hand side will increase by 4 times because there's a square. The directly proportional symbol shows that whatever change happens to the left hand side should be happening to the right hand side also. Means if you double the velocity, the distance should increase by 4 times. I'm taking a small change in velocity, there should be a big change in displacement. Means the graph should be something like this. Next part we are going to discuss some important tips for doing the practical paper. How to actually plot a graph. All these examples we have been discussing sketching graphs. So you need to be careful about all these steps while plotting a real graph. The first step is choosing the best scale. The data is given and you have the graph. How do you choose the scale for each axis? The graph will be filling almost the entire area of the grid. By rule, it should cover more than 80% of the total area. So how are we going to choose a good scale for it? Let's consider the x-axis, the time. What value I should write at each of these points? So let's see a method to find the best scale. What you need to do is first find out the range. Range means the maximum value minus the minimum value. That's what you call range. So the entire range I'm going to represent here, and now I have to count how many big divisions are there. Including the first division, I'm counting everything. So totally I have 10 big divisions. Now I'm going to divide the range by the number of available divisions. So I'm getting 0.132. But you cannot plot 0.132 for a division. It will be very awkward. You have to round it off to a whole number which is bigger than that, like 0.2. You should avoid the scales with multiples of 3. Like 0.3 you should not choose because then it will be very difficult to further divide. So the best scale for the x-axis here is 0.2. The first value is 1.7. You don't need to start from 0. Our aim is to get a big enough graph. For that you can always break the axis. For example, I am starting from 1.6. I have to plot with a difference of 0.2. Means the next value should be 1.8. So this is the best scale for the x-axis. Same method I'm going to use for y-axis. First I'm going to find the range, maximum minus minimum value. Then I'm going to count how many major divisions are there. So here also I will get 10, like starting from here 1, 2, 3, 4, like I will get 10 because this is a square grid. But in the exam you may get different numbers. To find the scale, I'm dividing the range divided by number of divisions available. And I got 0.322. So I can plot 0.4 or even 0.5. I'm taking 0.5 as a scale. The first value I have to plot is 4.33. So I'm starting from 4. Then I'm taking an interval of 0.5. The next step in plotting the graph is marking the points. You can mark the points in two different ways. Either you can mark all the points using a cross, or you can mark the points with a dot and a circle around the dot. And you need very high precision in marking the points. Even a small variation of half of a division, even a small variation of more than half of a division, you will lose marks. Plotting the best fit line. This step will need a lot of practice because the data points will not all come along a single straight line. You have to use a ruler. Better to use the ruler first in the vertical direction and see which will be a best fit line. And what's the condition for drawing a best fit line? There should be equal number of points on either side. Remember, the condition for best fit line is not passing through maximum points. The condition is there should be equal number of points on either side approximately at the same distance. And whenever they say best fit line, it doesn't necessarily mean a straight line. There can be best fit curved lines also. How to calculate the gradient from the graph you have plotted? Always you need to choose the maximum possible points. For that you can even extrapolate the graph to any distance you want. Then mark one point as x1 and y1 and another point as x2 and y2. Then use the equation, and remember, most of the time there will be a unit for the gradient. So gradient is not just a number, it is a physical quantity, so it will have a unit also. How are we going to calculate the gradient if it's a curve? For example, this question, they are asking to find the maximum speed. And you know, speed is obtained by the gradient of the graph. So maximum speed means you have to find the point where the gradient is maximum. As you know, you have to plot tangents to find the gradient, and as the tangent becomes more and more vertical, the gradient also increases. You have to find a point where the tangent is most vertical. So that will be coming at this point. So I'm going to plot a tangent just touching that point. So you have to extrapolate the tangent so that you can get a better gradient. And now I'm going to find the gradient of that tangent line. One point I'm choosing as x1 and y1. y1 is 0. Then another point I'm choosing as x2 and y2. How to find the area under the graph. You will get different shapes of the area. One of the most common shape is a rectangle. The area is length into breadth. If it is a triangle, the area will be half into base into height. Any type of triangles you can take half BH. But sometimes there will be multiple areas under the graph. The total area under the graph is adding these two areas together. Sometimes the area under the graph may be a trapezium. The area can be found directly using this equation, half a plus b into h. These are all very regular shapes like rectangle, triangle and trapezium. What do we do if the shape is not regular? For example, this is a velocity time graph and you are asked to calculate the total displacement. You know the displacement is the area under the graph, but we don't have any particular equation to find the area under the graph. In such situations, the only way is to count the total squares. First I am counting all the big and complete squares. There are 41 complete squares. Then I'm going to count the pieces. Like I can combine two pieces together and consider it as a square. So you can see same colored pieces I'm taking as a square. You can go on adding more and more squares. And finally I got 52 big squares. Now how do you find the displacement? One square area is, you can find from one division on the x-axis multiplied by one division on the y-axis. So y-axis is 100, x-axis is 0.1. So the area of one square is 10 meters. Then what's the total area of 52 squares? So 10 into 52, that is 520 meters. This is the total displacement. With this, we will conclude the discussion about graphs. Thank you.